Okay, let's get started. Can you hear me well? So welcome to this session. We're going to talk about components and what you can build with components. And in this case, you can see a few components there. My question is, what would you build with those components? Any of you want to answer? You? There's no trick. A tank? Not really? Any other? Yeah, a car. Yeah, you're right. But it turns out that we, as developers, tend to build, we try to select the best architectures, the best components, the best technologies, the best approaches, kind of the state-of-the-art architecture. And when we're done, we try to build anything with that. So even a bicycle, even when that bicycle is kind of cool, but of course, we also build cars with it, but this is kind of the main topic I want to highlight. So we need to use different components, different technologies for different purposes. Okay, that's kind of the point of this session, and then showing you the broad spectrum or all the technologies we have for development at Microsoft, and also relating those technologies with different approaches. So with that, I'm going to introduce myself. My name is Cesar de la Torre. I work as a .NET Product Manager for the DevTools division at Microsoft Corp in Redmond. And let's start. So first of all, I want to say that this session is not just a single session. We created like a mini track for line of business application development. So it's kind of the umbrella or the global vision. And then we will have many different related sessions going from one extreme to the other. Like, for instance, we will have a few sessions about data-driven applications on LightSwitch from Beth Massey, and also about entity framework and all the any kind of data access you can use. Then we can go to another type of sessions, which is kind of the other extreme for mission-critical applications. And we will be focusing on a concrete approach, which is domain-driven design. And we'll have tomorrow great sessions from Jimmy Nilsson and Per Rovegaard. They are here, and they are great authors as well about domain-driven design with .NET. Also, Julie Lerman about entity framework, but how you can use entity framework with different models and like applying domain-driven design approaches. And Greg Yan, he's a great speaker and for event-driven and domain-driven applications and high scalable applications, event sourcing, and so on. And also another important sessions about dependency injection and IOC containers for loosely coupled architectures. And finally, we will have other kind of sessions regarding Windows applications modernization, which is more related to mobile apps for tablets, for phone. But from a business applications point of view. So it's not just creating a Windows 8 app or a Windows Phone app, but thinking about business applications and the requirements we usually have, like a heavy data entry and so on. So when we are going to start a project, a development project, we must think about the technologies we want to use. And I always think like we could compare that to a tree, where the tree is not just the tree you see, but it is based on its roots. So to me, the roots of the tree are like the business priorities of your application. So you got to think on those business priorities before selecting any approach or before selecting any technology. Things like what is the priority for your application and your business? Is it about short time to market, or is it a large application and you're going to need a long-term investment? Or is it a small, medium departmental application, or is your application more about enterprise and mission-critical application? Are you engaging customers directly, like having a direct connection with your customers, or you're just creating an internal application to run your business? So those kind of questions should impact on the approaches and the technologies you are choosing. Like things like you could go to a rapid application development, versus a more complex and loosely coupled architectures, or data-driven versus domain-driven, and we will be talking about that later on. Or depending on if it is an application of engagement, you want to engage customers, or a modern application versus a traditional or established pattern using a desktop application. Those questions are not really directly related, all of them, but probably you've been thinking about the same questions when you're starting a project. So here we have all the Microsoft Development Platform technologies classified depending on the client software, application services, infrastructure services, and even the deployment environment. We will be talking about most of them, but not right now. I'm not going to spend all the time going square by square here. But this is kind of the goal. What technologies should we use for each purpose? Because you have several technologies for services, or for presentation, or for web, etc. Right. So first of all, I think we can put your application in two different buckets. So we can have small, medium business applications on one hand, or large and mission-critical applications on the other hand. And probably your application is going to fall in one of those buckets, or something in between, but the approaches and the priorities are different. So for instance, if we're talking about a small, medium business application, your priority is more about productivity, development productivity, and you want a technology that is going to be easy to get started, and those are the most important priorities for your application. On the other hand, if your application is going to be, or it is a large mission-critical application, then your priority is more about the long term, and thinking about your core business is going to be a long-term investment. So probably the technologies and even the approaches, which are even more important, are going to be different. So on the left, so for small and medium business applications, the approaches we could use are usually more data-driven development, simple approaches, RAD. And when I mean data-driven, it's like an application where you are just reading and saving data. We will talk about that later on. And on the other hand, if you are talking about, or you want to build a mission-critical, large mission-critical application with a lot of business logic in it, the approaches probably should be different. You could use domain-driven design or similar approach, decoupled architectures, and like I said, your priority is more about the long-term maintenance. So you want it to be agile, but not just at the beginning, but also in the long term, because your application is going to be evolving all the time. Something I want to highlight as well is that when I'm talking about applications, I also mean subsystems, or parts of applications. Because if the application is small, it's okay. But if you have a large application, maybe you're going to have different subsystems, and each of those subsystems could have a different approach. Could be the core domain of your system, then the approach should be one, or you could have other collateral or more simple subsystems, just maintaining tables, for instance, and then you should apply other approaches. Okay. So we're going to start with small and medium business applications. And usually that kind of applications are like data-driven applications. And what I mean with a data-driven application is not just that we are using data, but that it is a CRUD application. So basically you are creating data, reading data, updating data, and deleting, like a master detail scenarios, but pretty simple. You don't really have a lot of business logic in here. Then the issue with this kind of applications is that you start thinking just So if it is a simple application, there's no issue, and this is the right approach. But if it is going to evolve and grow, and you're going to have a lot of business logic, then the issue is that if you see that the user in any application, in order to do a task, he has to know a lot of things in his knowledge, or even following a manual. So in order to do a task, this task, I got to go to this screen and then do this, do that, and go to the other screen, and that's kind of the whole process I need to do. That is because that application is not really domain-driven. It's not driven by the task. It's driven by just saving data, and then the user has to know what to do, and that's an issue. But in any case, many business applications are just about saving data, like contacts or whatever the concept, and it's a right approach for many applications. So a few scenarios for data-driven or small, medium business applications. If we are talking about a desktop application, we could be using WPF or even WinForms or apps for Office, which are running within Office itself, Office client. And then we will probably would be invoking or executing remote services. And finally, we could have components, entity framework, or ADO.NET accessing data, and you could deploy it on premises or in the cloud. Second scenario would be similar, but in this case, it is a web application instead of a desktop application. So it's kind of similar in the server side, but we would be using any of the web technologies we have, like, of course, HTML5, light switch HTML5 client, and then using ASP.NET web forms or MVC or light switch in the server. And then same about the services. So in this case, you are looking more for, like I said, more about productivity, and that is more your priority. So I want to highlight light switch for this scenario for web and small, medium data-driven applications. And I'd like to highlight that light switch HTML5 client was released a few weeks ago in April. So one question, how many of you do know a light switch HTML5 client? Okay, just a few. So that's what I thought. So that's why I'm going to do a demo about that. And like I mentioned, it is a great technology for web data-driven applications. So that's going to be my first demo. Let's go to my computer. So you can have a light switch HTML5 templates if you install the Update 2 in Visual Studio 2012. So you'll have those templates. I select the light switch HTML5 application, light switch demo TechEd. Okay. It's going to take a few seconds. So this is an empty project, light switch project, and it has basically two concepts, very simple. Just tables on one hand, data, or screens to use or to create the application. So when we are adding a table, you can create a table just right here, and it's going to be like SQL, complex SQL embedded in your application, like just a file and using that file. Or you could also add external data sources, like another external SQL database or SharePoint lists or OData services. So now I'm gonna create a simple table. I'm gonna call it conferences. Then a few fields, conf name, string, conf date. You'll see that there are special data types. Conf email. And you see even the email address. So the data type is important because we're going to have data validations just out of the box without doing anything. So that's a simple table. Then we need to create screens. I want to highlight that when you are creating a table here, it's not just a simple table in the database. Underneath, LightSwitch is creating a service, OData service. So just doing that, you're going to have the table and the service and OData service, and you could even consume that service from any other application or from .NET or whatever. But here it's going to be kind of transparent. So now we add a screen. Let's call it Browse Conferences. And we link this screen to our table, Conferences set. On the second screen, just for editing, add edit conference on the same data. Okay, so something important is when you create a screen, because it is looking at the related data, then you have that tree, controls tree, with all the data you're going to show. And just moving those controls in different order, or maybe changing the type of the control depending on the type, that's the only thing you need to create the screen. Okay, so you don't even need to paint the screen. It's going to be rendered created using your data and controls. So just doing what I did with a single line of code, the application is going to run, and I will show you. But you can also extend these kind of applications. So if we are in the screen, because it is a HTML5 screen, you can extend it, and with JavaScript, like before apply changes in this event, I could write JavaScript code here. Or if I go to the tables, which as I mentioned, it is really a service as well, I can extend this using .NET. Like when it is updated, I could write C# code here, doing whatever. I will show another example later on extending this. So if we just run the application, and remember that I just created the data on the screens, and that's it. Oh, sorry, I didn't add the buttons. So let's add one button. So add edit new conference, and another one to edit selected. This is going to be the home screen. Okay. So I can add a conference, like TechEd demo. You see that if I don't write it properly, I get an error. Add a date. Sorry. And is that simple? I also want to show another example which is more complex, and we will use it later on in order to communicate different subsystems or bounded contexts. So this one is another example. So you can extend it and use CSS styles, and so this is another application, LightSwitch, but it has very few lines of code. Just when I'm extending it, you can edit, you can see the conference registered users, the sessions, and so on. We will talk about this model, this application in a few minutes. Okay, let's switch to the demo. I mean the PowerPoint. So now we're going to talk about the other extreme, large and mission-critical core business applications. And in here, I mean, what do you think about the technologies? So in reality, we can use most of the Microsoft development technologies, so all the lower level technologies, more granular. I would highlight, like, when we are creating services, the recommended or by default technology you should go is ASP.NET Web API. If your services are HTTP, REST, OData, you should go first to Web API, because there is where Microsoft is investing a lot for the future. But I mean, it has to cover what you need. So if you need other protocols, other or complex web services standards like WS Star or other protocols like TCP or name pipes or MSMQ, then you should go for WCF. And then regarding the web technologies, because we are talking about a large mission-critical application, you want to have unit testing, a better separation of concerns, and so on. Probably the right technology would be ASP.NET MVC. So you have that with a better design in order to grow in the future that application. And you could use Entity Framework for data access, or even your own approach using ADO.NET. Security, Service Bus. We will be talking about Service Bus later on in a few minutes. And about the storage, you could use SQL or NoSQL in like the Windows Azure tables in the cloud. But the point to me is that probably for large mission-critical applications, even more important than the technologies you can use are the approaches you are using, or you're using for designing your application. So I just put here quite a few approaches or patterns that you should use in mission-critical applications. Make no mistake about this, because you should also use those patterns in small, medium applications, but for mission-critical, they are fundamental. I mean, if you are not using those kind of patterns and approaches, then in the long term you will have issues. Okay. So you can see many enterprise patterns like coming from Martin Fowler or domain-driven design. You can read a lot of information about that from Eric Evans, from Jimmy Nelson. That we're going to have a session from him here tomorrow. Van Vernon, or about CQRS for high scalability applications, like Greg Young. It's not properly written there. Greg Young is going to deliver a session about event-driven and CQRS on Thursday. You would also need like loosely coupled architectures, or the coupled architectures using dependency injection, IOC containers, and any container, either Microsoft containers like Unity or MERF or other non-Microsoft containers. And solid principles like single responsibility principle, open, close, and so on. I'm not going to talk about all that information, because we will get deeper about those approaches in the sessions we're going to have tomorrow and on Thursday. But I think this is kind of the most important point for mission-critical applications. And then you should map those approaches to the technologies you want to use. And finally, and I think, to me, this is the most important slide of this presentation, especially when talking about mission-critical applications, is that when you have a large application, like that application could be a large application, you will usually have many subsystems. And what I want to highlight is that you should have different approaches and different architectures per subsystem, depending on what kind of subsystem you are talking about. If it is a large application, but maybe the first subsystem I have is more about data maintenance, just maintaining tables, so or just because it is a data-driven area of my application, the architectural approach could be simple. Could be having just a user interface and data access layer, and that's it, and accessing the data, and that's all. But then you might have, of course, in a mission-critical application, subsystems where that is more for your core domain. That is where you want to invest for the future. You want to protect and isolate your code, your business rules, so it is not like impacted when you're changing the technology. That is what you want to really grow and evolve and really have a really good testing in that area. So in those subsystems, you could go for domain-driven design approaches or other similar approaches following design patterns, or could be another bounding context about CQRS, which is going to be a very high scalable subsystem with many users competing for the same resources. So you can decouple the reads from the writes in your application. So Greg Young will talk about that on Thursday. Or you could even have another legacy system that you are just treating like a black box, and you will be connecting that to the other subsystems. And then something I want to highlight is that we are going to need communication between those subsystems, and the way to do it should be asynchronous. So we could implement our own event bus, like it could be my own event bus in memory if all the subsystems are within the same process. So it's just putting events and reading events. I will show an implementation in a minute. Or if we have different distributed servers, we could use, or we could implement that event bus underneath using a service bus, like a Windows Server Service Bus or Windows Azure Service Bus. So I'm going to show you now a more complex demo. Okay. So here we have an application where we have quite a few clients. We have, I will show you later on, Windows 8 client, even a WPF client, a web application, web application. Those are the clients. And the light switch as well, which is the client I showed you a few minutes ago. And then we have the server side, where we have a few, well, two subsystems, or two, like in DDD jargon, two bounded contexts with different boundaries, and then the web application. So let's see first the web application. And those two subsystems are different. The first subsystem, which is called the conference context, is data-driven. It's just ASP.NET, MVC, and single-page application, JavaScript. But we are just reading data and saving data. So that's what we're going to see now. And the other subsystem is more for a concrete area of my application where we have more business logic. And that's a different approach. So let's see first the web application. So it is a single-page application. So underneath it is MVC as well. But we have a lot of JavaScript, and we're using libraries like Durandal and Knockout. So we have model view models approaches in JavaScript. And if we go to main using Durandal, we can configure like the navigation with a router with map route. We can point to the different views in Knockout. I will show you now the views. So if we go to we have view models and views. So the views are just plain HTML. And then we have the related view models, which is JavaScript, like the view model for the conference. And in here we have the methods calling to web services, like this one. I have when I save a conference, I will call to a web API service in the server. So let's run the application, and we're going to debug it so you can see how it works. Oh, sorry. Let's close this page. So this is the application. The application. Most of it is data-driven, like I said, and then we have an area which is more domain-driven because it has more logic. So if I'm navigating, you see that it is loading very smoothly. It is not really reloading the whole page. It's just loading different like views. I'll go to the home. Or I can see the conference schedule here. Or I can go and manage conferences. I can edit this conference, and we will use it later on in order to integrate this subsystem with the other subsystem. But as I said, it is more a data-driven application. And then if we enter into any of the conferences and I want to register using Facebook authentication, which is the authentication we're using, here is where we are using really underneath another subsystem or another bounded context with a different approach, more like domain-oriented or domain-driven, because here we have a lot more of business logic, like taking into account the available seats or how is it going to impact when I'm registering, if I'm registering just one guy or several people, or a potential payment gateway, and so on. So that is where we have another subsystem, and we need to communicate both subsystems. So regarding the data-driven subsystem, I'm going to show you the internal area. You'll see here the conference context, which is the data-driven subsystem. We have a model. In this case, it's based or using POCO entities, and then we will use entity framework. But because it is data-driven, if I edit one of the entities, like conference, you see that it is just a class with properties, with data, name, room number, description, Twitter, a bunch of fields, and that's it. That's an entity which is just for data, for a data-driven approach. It is what we can call an anemic domain model because it has just data. It has no business logic within that entity. Okay? But for a data-driven approach, which is this model about, it's okay. And then we have just repositories or data, like similar to data access classes, and that within the data project. And you see that I have a conference repository, and within that repository, we are writing all the link queue to entities code, like this one, accessing the database or updating and so on. And it's that simple, that area. So we have the web application, JavaScript, knockout, calling web services, web API services, and then using the repositories, database, and that's it. On the other hand, if we go to the data-driven subsystem, which is the ordering context, the approach is different. We have several projects. You see, let's zoom a little bit. We have an application layer, domain layer, and then the infrastructure layer. And then underneath, we have a data access layer. So if we go to the domain, which is the core of our bounding context, and then we can see the entities. So the entities are also POCO classes, so just my own code it has no any dependency with anything at all. It's directly, so it's just a class. Then in this case, it is an aggregate root. That's a DDD term that you will, if you want to know more about that, it's like an aggregation of different entities. But tomorrow we probably will talk about that. But the difference about those entities is that there's not just data, but also we have business logic in here. You see that we have properties, but then we also have a method regarding when I'm changing the conference seats, the business logic I need to take into account, or when I'm creating an order, and so on. So it is more object-oriented. So any business rule regarding that data is within the same entity, and that's a rich domain. And then we also have repositories using unit of work pattern. And finally, what we can see also is the integration. So okay, we have two subsystems with different approaches and different data, but the data is related. So, because for instance, in the second subsystem, we have also the conference entity that we already saw, but it has different data. It has just the data I need for this other subsystem, although it is a similar concept. But I just need, in this case, I just need to know about the seats, available seats, if it is canceled, and that's it. And then anything related to the ordering subsystem. About the rest of the information of the conference, the other subsystem is taking care about that. Okay? But we're going to need to communicate one subsystem with the other, because if I create one conference, then the other subsystem has to know about that and has to know the minimum data related to that conference in its own schema, okay, in its own model. So for that, we are using, like I mentioned a few minutes ago, an event bus. An event bus is just something where you are putting a message and then like a publish subscription pattern, and then the other subsystems or bounded contexts are getting that message and executing something or accordingly. So I'm going to show you the event bus I'm using. So it's really simple. First of all, we need an interface. It's iEvent bus, just two methods, publish and register handler, which is the event handlers I'm going to need in order to know that there's an event in the event bus, and I'm going to process that, or to publish any event in the event bus. The event bus, as I mentioned, could be something simple, like an in-memory event bus. In this case, I have my own implementation of the publish and the other method, and I'm using just a hash set in memory to put all the messages and then grab all the messages back from the other subsystems. That would be enough for a single application, which is everything is running within the same process. Like if all the subsystems are running within IIS and the same application pool, that could be enough, everything in memory, and that's what we're going to use now. But sometimes maybe the different subsystems are in different processes or even in different servers. So then that event bus is going to need another implementation. Like you can base that implementation in any service bus. Like in this case, I have another implementation using the Windows Azure service bus, and we are using topics, so I'm able to publish events and then get those events if I'm subscribed to the bus. So we're going to run again the application, and let's see how it works. We can debug it and see all the points where we are connecting or communicating in an asynchronous way those subsystems. So if I go to the data-driven module, and I'm managing a conference, I create a new conference. So let's put a logo, TechEd, TechEd demo, Caesar. Let's start 9 p.m. Let's put any description here about TechEd, city, New Orleans. You see that it is integrated with the map. Conference Center, .NET, Microsoft. Let's put a single room, and let's say we have 600 seats, 6,000 seats. And then when I'm saving this, we will go to the web service, well, JavaScript first, then the view model in JavaScript, web service, and we will save it in our regular database. And after that is where I'm going to create an event and send it to the event bus. Okay, so let's save it. You see, we are in JavaScript now. This is a view model in JavaScript. If I go on, it's going to call my JavaScript API I created in order to call a web service, a web API service using jQuery Ajax. So now I'm calling that web service, and then I am now in the server. This is C#. As you see, this is a web API service, the conference controller, API controller. So I'm getting a post where I want to save that conference in my system. So what I'm doing is just using a repository. I'm adding that conference definition, and the repository is saving that using Entity Framework. This is the method add in the repository. You see here, we are now in the conference repository. So I just save it into the database. When I call the context save changes in Entity Framework, now it is saved recorded in the database. And now is where I'm creating an event. An event is just like a DTO, just like a simple class with data I need to propagate to the other subsystem. So here I'm creating that event, conference created. And because if it is an event, it is in past tense. So something happened in that subsystem. That is the event. Conference has been created. I create that event. And then I publish that event with the information, the number 6 of seats I need, and just the information I need in the other ordering subsystem. I don't really need the whole information about the event, about the conference, just that information. And I just publish it. And when I publish it, I'm going to go ahead. Then my event bus, all the event handlers that are subscribed to my event bus are going to get that message. So I'm going to go ahead. And now, it's now publishing. And you see that it is using right now the implementation of the in-memory bus. You see I'm using the hash chat. So just going ahead. And now I got that message from the other subsystem with my my conference created handler. Okay, so this is another subsystem, the ordering application subsystem. And here I have to handle that message doing whatever I need. In this case, I just need to go ahead and add that conference to the other subsystem model, which is even a different database in this case. So just take into account that event and save it. Okay, and that's it. And now, suppose we are using now the other data-driven project, which is using light switch. And here, the light switch project is in a different process because it has a different deployment in a different website in IIS. So that's why the in-memory event bus I had won't work because it's a different process. Or think about if it were even in a different server. So because all my components in this application is loosely coupled. It's using dependency injection. So the implementation of the event bus is also using dependency injection. So I can go to my dependency injection registration, which is this config. We are using Unity. Here you can see all the types registered in the Unity container. So what it means is that when my system needs an object of this type, like any type, let's go and see like a repository. If I need an object of the type iConference repository, I'm saying here that it has to instantiate a class called conference repository. So in a similar way, regarding the service bus, I'm saying that when I'm instantiating an object of the type iEvent bus, I was using the implementation of the in-memory bus. But I can change it, just changing this line and saying that I'm going to use the Windows Azure Service Bus implementation, or could be a Windows Server Service Bus implementation. It's just the same API. Just changing this line, so it is decoupled. It's not impacting the rest of my code. I don't really have to change anything else at all. And when I run it again, I run the application and then the light switch subsystem. So this is the application running. So it is waiting and registering all the event handlers. Right? And then let's run the light switch application. And well, before running it, I want to show you the tables, the conference table we have, and here it is the extension point. So when the conference is updated, I'm calling to my event bus. So let's run it. And now it's going to go through the Windows Azure Service Bus. So instead of adding a event, here we see the conference we created. Now we're going to change the number of attendees. Let's put this number, and I just go ahead and save it. You see this is light switch, but the service side, so it is .NET in the server. And here we are calling to my bus, event bus. And now it is using the publish in Windows Service Bus implementation. You see I'm creating a message, a broker message, and then sending that message to the Windows Azure Service Bus. And then we got that message from the other subsystem. Now I'm in the ordering application subsystem. I got that message with the new number of seats that I must be aware of that and acting in accordingly. Okay? And that's it. Okay, let's move on. Or before moving on, if you have any question about that, I know that I've been talking about many concepts or even a few topics or domain-driven design concepts that if you don't know it, please go to the other sessions where we will get deeper on those concepts. But if you have any question, go ahead now, and I'm going to move to another area. Yeah?
I missed the beginning. Are you using EF at all in this demo?
EF, Entity Framework? Yeah, I'm using EF. So all the repositories you saw are using LinkQ to entities. Okay? But I'm using POCO entities, so just it is just my code first, so it's not really coupled to Entity Framework. Yeah? Yeah, so the difference between single-page application or multiple pages is that if you are using just plain MVC and you have multiple pages, then every time you go to a different page, you have to load that page. It's another round trip to the server unloading that page. And when you're using a single-page application, the user experience is more like it's smoother. It's like you load the application, and then when you are changing from one screen to another, it's like you're not loading the application again or a page. It's just moving subsets or views, and it is smoother. And you can put transitions like I'm fading in, fading out, and it's going much faster. It's just a matter of user experience. But you gotta use a lot of JavaScript and libraries like Knockout for model view model is on JavaScript and so on. We can talk later on about that. So on the third area I want to talk about is about application modernization, or modern times, like I like to say. So up to now, we've been talking about established patterns and whether our application is a client application, or a server in where we have all the business logic and so on. And then those established applications are evolving for many scenarios to emerging patterns. So in the client, we're moving from PCs, or whether it is a desktop application or WPF or WinForms, or even a web application for the PC, to any kind of device and mobile devices. And in the server, we are moving from regular servers on premises to elastic services in the cloud. That's what we call emerging patterns in both areas, right? So devices and services. So up to now, I've been talking about established application patterns, which are the foundational applications for the businesses. Could be web application, desktop application, services, and we are like focusing on existing business processes. And as I mentioned, and I've been talking about, we can have small, medium business applications, or large mission-critical applications, or even something in between. But Microsoft's vision about this is, and about modern applications and emerging patterns, is that we need to move on and evolve those applications, those business applications, and using those emerging application patterns. So it's basically two pillars. One is moving from more traditional applications to new experiences, basically new devices and mobility, innovation, and so on. And on the other side, on the server side, is going from fixed on-premises services or even just client-server architectures and evolve that to the cloud. And so we can have an elastic cloud for those mobile devices. Because in many cases, if you have a new scenario and you have many more mobile users and potential volumes of new users that you don't really know how many new users you're going to have with those new scenarios, then the cloud is perfect for that. Because if you have just a few users, you just need a few resources in the cloud, or if you suddenly get many more concurrent users, you can grow up your resources in the cloud in a very quick and elastic way. And that is really a modern business application. It's not just the client side or the app for the device, but the whole modernization of our current applications in the enterprise. So if we talk about application modernization, we can see different areas. Like one area would be web application. I want to modernize my application, which is now it is just a web application for a PC, but then I want to take into account for that web application other form factors, other devices. So for that, I'm going to switch again. And I'm going to show you in the same example we have, we are also using a feature in MVC, which is based on the extensions of the views. I'm going to close this. So you see that my base page in MVC is layout, but there's also the same page with different postfix called mobile, and like in an automatic way, MVC is going to detect the user agent of the browser, and depending on that, it's going to go to one or the other way. So the rendering is going to be different. So if I run again my example, so here we have the web application with it's been rendered like for a large form factor. If we make it smaller, like if I'm using a smaller tablet, it's okay, it's working. But then if it is too small, I mean like a mobile phone, then I mean it won't be okay because you will need to do a lot of scroll and so on. So you would like to have a different rendering. So here, if I just change the user agent, so I'm going to simulate that I'm accessing the same application with a smartphone. I'm going to change the user agent. So instead of the default, which is IE10, I'm going to use IE10 for Windows Phone 8, or it could be any other user agent. And then if I just refresh the page, you see that it has a different layout, especially made for a phone. Okay, now if I change it again, and refresh, we have the original. And regarding the SPA, like we were talking about, you see that it is not really reloading the whole page. It's just reloading small areas. And I put like a fade on and fade in so you can see the transition between the different views. Okay. And then we can modernize our different scenarios of our application using native applications. So you could create a Windows Store application for Windows 8, for tablets, for the Surface, or a Windows Phone application, or even native apps for non-Microsoft devices, like for iOS or Android. But also, you can use, in those cases, you can use .NET. So you can use .NET for Windows, or you can use C# and reuse your C# code using partners technologies like Xamarin, and you can reuse a large percentage of your .NET code in different devices. I just want to show you just maybe running it in this example. We also have other clients, like those two different Windows 8 store applications. This one is using JavaScript, but it's going to be a native Windows Store application. You see here, it's using JavaScript. Or we have another one which is using .NET and SAML. And the good thing also we made here is that for all the .NET applications, we also are creating a Windows 8 phone application in .NET. For all the client applications that are using .NET, we are using the same library regarding when the logic or when we are calling web services. So it is a library which is using the same code for different platforms. So I can reuse it for .NET or for Silverlight, for Windows Phone, etc. So it is a PCL, a portable class library, reused or shared in all the clients. So I'm just going to run it because we don't really have a lot of time for this. But I have this application for the organizers of the conferences. I can log in using Facebook. So this is a modern Windows 8 application. You see here the conference we created, or it doesn't have any session, but we can go to TechEd, US. You see different sessions we have here. We can go into any session. We can see the comments, the attendees. So this is the idea of the mobile and modern applications are about using concrete applications for specific scenarios. So in this case, we have this application for the conference's owners or for the conference organizer. And he will use that application while running the conference so he can see what's going on in the sessions, what people are saying about the sessions. Or we can have another application for the attendees, which is this one. And in this case, the attendees are the ones who will be using it. I will log in again. So I see all the conferences, and then if I go to one of the events, I can see information about where is the conference or about any session. I can see comments about the session, or I can even see where my friends that are also in Facebook, and if they are attending this session, I'm aware of that, or I can see the room map or whatever. So the idea is having different modern applications for concrete scenarios. Okay, on that switch here. Yep. Could you repeat?
Is there similar support? It seems like we're able to quickly generate a Windows phone application running .NET. Is there similar support or portability to Apple or Android?
So when you're talking about iOS or Android, it's not really .NET. It is an implementation from Xamarin. So you can reuse all the C# code using Xamarin. I mean, Xamarin is based on Mono. If you don't know Xamarin, you probably know about Mono. So it is like the evolution of Mono. So you can reuse like 75% or 80% of your code of the application, C#, and using Xamarin, you can create other applications, native applications for iOS and Android. Okay, then you will need to use just for the view of the application, you will need to use the concrete technologies for the other platforms. But most of the code could be C#. Okay, so yesterday we had a session from Xamarin and other partners as well. If you take a look to the session, you will see. And finally, just about the services, like the modernization would be like moving from on-premises to the cloud, or even to a hybrid cloud. And if you are in an enterprise, large enterprise, a hybrid cloud would be like fundamental, because you just don't want to have a modern application isolated in the cloud, but you want to have into account your enterprise constraints to propagate security, etc. So this is the demo I just did, and this is like a quick summary. We don't need to read it again, but it's just positioned in different approaches and different technologies depending on what bucket are we talking about, like small, medium business applications, mission-critical business applications, or the emerging patterns and modern applications. So with that, just a few takeaways I'd like to highlight. First of all, like I said quite a few times, you need to select the architecture approaches and the technologies depending on your application priorities, on your business priorities. Second, in large applications, please do not select like the top architecture and then you are doing everything using that approach and that architecture. You got to think about what kind of subsystems you have, and if it is your core domain, you should use one approach and different technologies. If it is a collateral subsystem or something which is very data-driven, then you could use other technologies. And finally, you can modernize your established applications. Like if you have a large application, enterprise application, you can also create new bounding contexts, new subsystems, which are decoupled and maybe communicating with the other application in an asynchronous way using a event bus underneath using any implementation, like your own event bus or a service bus. Here we have a few details about the subscription, resources. So I'm just going to point to the other sessions so you can be aware of that. Because I talked about many approaches, the different concepts and different technologies, and so you can be aware of that. And with that, thank you. I want to thank you, and yeah, thanks a lot. If there